Let's take another look at polynomial division. You've been working to divide polynomials using the sharing model and the area model, but we can perform polynomial division without using the sharing model and the area model. We call this solving symbolically. When we're dividing without using these models, we need to divide each term in the polynomial, the dividend, by the monomial, the divisor. Our laws of exponents are going to come in handy. We can also verify our answers, so we can check our answers by applying the distributive property. The distributive property is what we used back when we were multiplying polynomials. To take a look at solving polynomial expressions symbolically, let's start with this example. We have 14x squared plus 12x divided by 2x. Now, when we're dividing a polynomial by a monomial, each of the terms in the polynomial, which is our dividend, must be divided by the term in our monomial, which is our divisor. That means that the 14x squared must be divided by the 2x, and the 12x must also be divided by the 2x. Now, if we look even closer at this, the numerical coefficients have to be divided, so the 14 and the 2, and the literal coefficients have to be divided, so the x squared and the x. The same is going to happen in our next term. The numerical coefficients have to be divided, and the literal coefficients have to be divided as well. Let's solve for this. 14 divided by 2 is 7. X squared divided by x. With our division here, we have to keep the base the same, subtract our exponents. Keeping our base the same, we would have x. Because there's an assumed 1 on our x here, 2 subtract 1 would mean that 7x has an assumed exponent of 1, which we don't typically write. Moving on to the next term, 12x divided by 2x. 12 divided by 2 is positive 6. Now, this is a concept that's often difficult for students to understand. We have x divided by x. Any number or any variable divided by itself is simply 1. Students think that they cancel, but they don't actually cancel. They equal 1. And because 6 times 1 is simply 6, we don't need to write that out. So there we have it. 14x squared plus 12x divided by 2x is equal to 7x plus 6. Let's take a look at another example. Here we have 10p cubed subtract 5p squared divided by 5p squared. Remember, each of the terms in your polynomial will have to be divided by your monomial. That means that 10p cubed will have to be divided by 5p squared, and your negative 5p squared will also have to be divided by 5p squared. Let's start with the numerical coefficient in our first term. 10 divided by 5 is equal to 2. P cubed divided by p squared. Keep your base the same, subtract your exponents. P, 3 subtract 2 is 1, but we don't typically write 1 for an exponent. Let's move on to the next term, negative 5p squared. A negative 5 divided by 5. That's a negative 1. P squared divided by p squared. Because the terms are the same, we know that that's going to equal 1. Negative 1 times 1 is simply negative 1. We've solved this equation. So I've written out our equation from this example. 10p cubed subtract 5p squared divided by 5p squared is equal to 2p subtract 1. Did you know that we could verify our answer using the distributive property? Verifying our answer means that we can check our answer to see that we're correct. So we can check that our answer of 2p subtract 1 is correct. We can do that because multiplying is the inverse operation of dividing. So if we take our solution of 2p subtract 1, multiply it by our divisor of 5p squared, we should get our dividend of 10p cubed subtract 5p squared. let's check this out and see what we get. 5p squared multiplied by 2p subtract 1. Let's use our distributive property. The 5p squared must be multiplied by the 2p and by the negative 1. Multiply the 5 and the 2 and you get 10. P squared multiplied by p gives you, keep your base the same, add your exponents, p cubed. Moving on to the next term. 5 times the negative 1 is a negative 5. There's no literal coefficient with that negative 1, so it's negative 5p squared. And we did. We got the same answer as our dividend. So we know that our solution of 2p subtract 1 was correct. Let's take a look at one more example together. And just in case you're having some trouble understanding how to divide a polynomial by a monomial, I've got a couple of jot notes down here below. Remember, when we're dividing, we need to divide each of the terms in the polynomial, which is the dividend, by the monomial, the divisor. To do this division, we need to divide the numerical coefficient of the term in the polynomial by the numerical coefficient in the monomial. We also have to divide the literal coefficient of the term in the polynomial by the literal coefficient in the monomial. And when we're dividing the literal coefficients, we keep the base the same, subtract the exponents. We learned to do that when we were learning the laws of exponents. So let's go ahead and take a look at this example. We have negative 20y to the 5 plus 30y cubed subtract 15y squared. This is divided by negative 5y. So let's start with the first term, negative 20y to the 5 divided by negative 5y. Dividing the numerical coefficients, negative 20 divided by negative 5 gives us a positive 4. Y to the 5 divided by y. Keep your base the same, subtract your exponents. And if you need to, we can write in that there's an assumed 1 for our exponent here. Keep your base the same. 5 subtract 1 means that this would be a 4. Moving on to the next term, we have 30 divided by negative 5, which would give us a negative 6. Y cubed divided by y is going to give us a y squared. Keep your base the same, subtract your exponents. Negative 15 divided by negative 5 gives us a positive 3. And y squared divided by y, keep your base the same, subtract your exponents would be y to the 1, but again, we don't typically write that for an exponent. So there we have it. The quotient for this, 4y to the 4, subtract 6y squared plus 3y. And if we want to verify our answer, so if we want to check our answer to this example, we can multiply our quotient by the divisor, and we'll hopefully get our dividend. So let's take a look. Negative 5y multiplied by 4y to the 4 subtract 6y squared plus 3y. Using the distributive property, each of the terms in our polynomial must be multiplied by that monomial. A negative 5 multiplied by a positive 4 gives us negative 20. Y times y to the 4 is y to the 5. Next term, negative 5 multiplied by negative 6, that's a positive 30. Y times y squared, that's y cubed. keep your base the same and add. And then the next term, negative 5 times positive 3, negative 15. Y times y is y squared. If you take a look, we did end up with our dividend, so we know that our solution to that question was correct. So now it's your time to shine. Give this one a shot. I want you to solve and verify your answer. So copy it down on a loose leaf, pause the video, and come back and see how you've made out. Alright, so remember, each of the terms in our polynomial must be divided by our monomial. That means that the 24k to the 7 had to be divided by the 2k squared, the negative 18k to the 5 had to be divided by the 2k squared, as well as the 12k cubed and the 20k squared. So let's take it one step at a time. The 24 divided by 2 gave you 12. K to the 7 divided by k squared would have given you k to the 5. Next term, a negative 18 divided by 2 would have given you a negative 9. K to the 5 divided by k squared should have given you k cubed, because remember, we're keeping our base the same, subtracting our exponents. Next term, 12 divided by 2 would have been a 6. K cubed divided by k squared would have been simply k. 20 divided by 2 was 10. K squared divided by k squared is 1. And we don't need to write that because 10 times 1 is 10. So there we have it. Our answer was 12k to the 5 subtract 9k cubed plus 6k plus 10. To verify your answer, you needed to take your quotient, multiply it by your divisor, and you should end up with your dividend. So let's take a look at that. Using the distributive property, each of the terms in your polynomial had to be multiplied by your monomial. You've got lots of practice with that from earlier examples and earlier work. So 2 times 12 was 24. K squared times k to the 5, that's k to the 7. 2 times negative 9, that's negative 18. K squared times k cubed, that's k to the 5. 2 times 6, that's 12. K squared times k, k cubed. 2 times 10 is 20. There's no literal coefficient with our 10, so we just simply have 20k squared. And we did end up with our dividend, and so we know that our solution in our example was correct. Here's your to-do. For your entrance slip tomorrow, create a question to find the quotient of a polynomial symbolically. Don't forget to verify your answer by using the distributive property.